Hello and welcome. My name is Theophanos Vassiliou-Giolis and I'm a Senior Research Associate at the TU Berlin. Currently, I'm working for the Weizenbaum Institute for the Network Society. Today, I would like to talk about microservices and why identifying specific instances at runtime is of importance for testing, but not only. The subtitle of the presentation asks the question, when to trust your microservice test results. Trust and its counterpart trustworthiness are important concepts in human life, and we should not use those terms carelessly. So, what is trust? For IT services, Jürgen Berg has defined trust to be the willingness of a party to be vulnerable to the actions of another party, based on the expectation that the other party will perform a particular action important to the trustor, and irrespective of the ability to monitor or control that other party. Now, that's trust. The counterpart of trust is trustworthiness, or as the Cambridge Dictionary defined it as the quality or fact of being trustworthy. So in other words, the ability to be trusted. And again, I'm citing here Jürgen Berg. He defines trustworthiness as the demonstrated ability of the IT service provider to perform a specified action while adhering to a set of stated principles. So, what are microservices? Unfortunately, there's not a single definition on what a microservice is or what a microservice not is. So we have to rely on some common understanding of properties that microservices share. Basically, it is agreed that microservices are highly maintainable and testable. They are loosely coupled, and microservices are independently deployable. Two additionally commonly agreed properties of microservices are that they are organized around business capabilities and that they are owned by a small team. For us here, the first three properties enumerated are of importance, as they have a direct impact on testability. The other two ones, while still being important in our context here, well, we will focus on the first three ones. Other aspects of microservices are that they can be deployed either as a standalone service or service functions, like for example AWS Lambdas, in a self-hosted or a managed environment. And microservices can be accessed either directly, for example via the IP address and port numbers if you're using HTTP, or via gateways. Gateways are elements like API gateways, load balancers, and the like. Finally, the addressing of microservices can either be done statically or dynamically. If they are addressed dynamically, typically service registries are being used. The points that I've highlighted here in bold basically constitute the problem space. So I'm focusing on the following on microservices in managed environments, where microservices cannot be accessed directly, and where the addresses are dynamically resolved via service registries in a managed environment. Robert Martin, or how is he called in the community on the Bob, has once been asked on his opinion on microservices. And his answer was straightforward: microservices are not an architecture, but they are a deployment strategy. The decoupling and partitioning could and should be accomplished irrespective of whether the service boundary is imposed. The original poster now continues to ask, well, how easily can microservices be troubleshooted? And this is the actual point where I wanted to highlight. Troubleshooting of distributed systems is incredibly challenging and requires new tools and skill sets. At a certain size, an engineering team, a monolithic service will experience too many cooks in the kitchen class of problems. So with microservices, you just get more kitchens. And as another user states, more kitchens implies that you have more potential for grease fire. Now, let me give you a small example of what type of problems you might encounter. We here see a very small application consisting of 3 microservices, A, B, and C, and the client that is interacting with the application. So basically, the client would like to use the function f at microservice A, which in turn calls the function g and h. While this example looks neat and small, if we deploy this into a managed environment in the real world, we have to extend this a little bit. Now, we have the microservices being deployed in a managed environment, and it's shielded behind a gateway. As mentioned earlier, this can be an API gateway, it can be a load balancer, etc. And we have a service registry that are resolving the microservice names to the physical addresses. And therefore, they are managing the access to a very specific instance of microservices. So a client that would like to call the function f calls this function f at the gateway. One of the central promises of managed environments is the promise of fast and high scalability. To guarantee this, they pre-instantiate microservice instances so that an increase in demand can quickly be addressed. This is shown here in the picture by having multiple instances of the same service. The fact how many instances are alive at a certain point in time is configurable also per microservice by the operator of the service. However, a client that is using a service can and of course should not influence or even be aware which instance actually serves a particular request. Well, this is what microservice is all about. Now, where's the problem? Let's consider an already deployed and operable system. What happens if we are going to deploy an updated version in this example? In this example, we are deploying a new version of microservice C. We call this updated version C'. Now, what happens is that for a certain period of time, different versions of a microservice coexist. From a user perspective, we call this time the temporal blindness interval. Temporary because this, of course, settles over time as the managed environment will replace step by step all pre-instanced versions of C. Now, in the real world, this is reflected by the comment that traceability and logging is a big issue in microservices. And it's getting worse, and even of more importance, if you add microservices. Now, what has been encountered in the real world and by practitioners, Confero and Depender has enumerated 5 key issues that limit the testability of service-oriented systems. While this was in 2009, a lot of them are still valid for nowadays microservices. Let's start first with the lack of observability. For users and system integrators, microservices are just interfaces. While this is limiting white box testing approaches, it also limits the knowledge on what's going on within a microservice or behind a microservice. It's a black box. We don't know what a microservice will actually do. Secondly, we're talking about dynamicity and adaptiveness. This means that the inability to determine the component invoked. While in service-oriented architectures, in SOA systems, we might have a very dynamic description of which service is called when. For microservice, as we have seen, this is also true if microservices are employed in managed environments. And this goes together with the lack of control, as microservices are executed on an independent infrastructure and developed and operated by independent teams. Finally, not finally, as a fourth element, confer and depend, I have identified a lack of trust with respect to provided documentations. So we don't know whether a service corresponds to the documentation. We can even go so far to say perhaps a service provider is lying on what is actually being done compared to the documentation. Finally, we have the cost of testing, where we have monetary and technical barriers for repeatedly executed tests. And this is again also true in particular in managed environments. Now, to visualize this, let's take a very simple integration testing question. I'm just asking the question here, has the integration of microservice C with microservice A been successful? We take the initial example that we have seen in the beginning. Now, if I deploy service C and integrate it with service A, I would like to find out whether the integration was successful. Do the two services speak the same language? Do they speak the same dialect? Can they communicate? This is a typical. We can test this by replacing our client with a tester. The tester is using function f, where we know upfront that f has to use C because it will call H at C. And if the response to f is the expected answer, we say that the test case passes. We conclude that the integration of C with A was successful because of our background knowledge that A had to interact with C. As a side note, I should add that of course we are not only executing a single test to prove this, but multiple test cases to come to this conclusion. Now, what we have seen so far was the theoretical test case. It's much more difficult in the real world. Because now, if for example, we deploy C prime, a new version of C, C prime, and if we would now like to test whether C has been successfully, or C prime has been successfully integrated with A, well, how do we do this actually? Have I tested the integration of C prime? Has C prime been used, or have C been used? And if the test case was earlier successful, when we tested the integration of C with A, and I now get a pass, how do I know whether I tested the integration of C prime? The managed environment is making the trouble here. We have no control on what actually has been done. A simple approach to overcome this limitation could be, I just wait long enough. We can easily agree that this would not be very efficient, nor would it help us. Because the simple question, which service is contributing to my request, is simply not being answered. Which also means that as long as I cannot be sure which instance is contributing to a test result, I cannot trust my integration test result. How can I say that the integration of microservice C with microservice A was successful if I don't know whether microservice C has been used at all? Now, let's come back to the trust question. When talking about microservice and testing a managed environment, and I'm referring to my definition of trust that I've introduced earlier, I'm focusing here to the fact that a service demonstrates a property while adhering to a set of stated principles. And in our case here, I call the property instance identification and the stated principles IID protocol. If I have this at hand, and taking this all together, I would then dare to say I can only trust my test results if I can trust the used microservice. For me, the microservice is trustworthy if it discloses its identity by using the IID protocol. So, a service should disclose its identity. However, this immediately triggers the next question. Identity? What is the identity of the microservice? Now, let's come to our proposal. Now, what we propose is to introduce an instance identification for microservice that shall be disclosed. In order to minimize communication overhead, the instance identification shall only be disclosed on request. And an instance should be identified by its name, of course. So we have used here the names microservice A, microservice C, etc. Or whatever you call your microservice. Second, it should contain a version number, hopefully something useful as a semantic version number, so that we know roughly with which service we have talked. These two information elements already roughly characterize our instance. However, in practice, and in particular in the dev or scenarios in managed environments, two more elements are required to clearly identify an instance. First, the epoch time. So the epoch time indicates how long a microservice is being running in seconds. Finally, we include in our instance ID an element where we could embed additional information, like, for example, version control information, commit tags, or the like. We call this information the microservice instance ID, or in short, MID. Now, as microservices making use of other microservices, we would like to have an insight on the list of contributing services per function request. So, which additional services has been used by a microservice to compute the answer for one particular request? So we would like to see if a service A uses service B and C, we would like that service A discloses this information too. And if it's disclosing this information, we call this identifier then the complete instance identifier. And for us, this is the identity of a service. Now, to go even a step further, let's introduce the IID protocol for HTTP-based communication. In order to communicate the instance ID, we are proposing a very simple protocol here by using HTTP headers. As the first step, we will request the generation of an instance ID by providing the instance ID request header. A service is responding with a response header by including the requested information as outlined earlier. Optional elements of this protocol include elements for authentication in the request and for additional information in the response, as we have seen, for example, version control information or even the used services. I guess you will all agree that this approach is straightforward for the initial problem statement. So if a service discloses who it is and which service is being used, I know which service has contributed to this. Of course, this does not answer the question is, can I trust the information that is in there? But hey, we have to start somewhere. Now we have seen what IIDs and the IID protocol can do for us when working with microservices. But let's try to think it a little bit bigger. The underlying principle that we have applied is to increase trustworthiness by sharing information that goes beyond to the actual service, the data that is embedded in the actual service. We're disclosing information related to the component that is providing the service. We have done this in a structured, human and machine processable format. Now, our proposal, our idea is to include this principle into various types of applications, for example, mobile applications or IoT services or the like. Now, we are promoting the disclosure of information not only about used internal services, so in our case, microservice A, microservice C, but also the disclosure of information about used external services. So, have I used Wikipedia, or have I used an internal database, an external database by a third-party provider to compute my answer to a function, to a particular request? Now, if we go this step, we can even think of why not talking about which AI model I've used in my service, or that has been used while I'm providing a particular service. Why not talk about which algorithms have been applied? And as a last step, perhaps which patterns are covered here if I'm fulfilling a particular request. Now, this is all motivated through our research that we've done at the Weizenbaum Institute, also about privacy, but also about trust. You can say, if you think it a little bit over, what I'm proposing here is something like what SPDX is trying to solve for source code licensing or license compliance. So there we have a legal framework where we have to comply to legal requirements and therefore are collecting the information and validating this information. Now, why not do this not required by law, but in order to increase trust towards our users? The namesake of our institute, Joseph Weizenbaum, once stated, "A computer will do whatever you tell it to do, but that may be much different when you had in mind." In the spirit of this observation, our goal with this proposal is to reduce the surprise of the unknowns that occur when we are interacting with the computer systems, in our case here microservices, by introducing well-structured identification as a mean to improve the expressiveness of integration testing. Beyond integration testing, we have found out that if we are using information like this in everyday life of a developer, it does not only support the testing activities, but it also supports us very well in the iterative development process. Beyond the fact that it adds some very limited engineering overhead, it brings a direct reward. The direct reward is trust. Trust in what am I doing as a developer. Trust in my test results if I'm acting in my capacity as a tester. Now, if you ask yourself what's the one key takeaway, the one key takeaway I wish you have from this presentation is whenever you design, implement or run a technical system, don't promise only that your system is trustworthy. Document for and communicate to the end user which components, services, models, or even algorithms your technical solution is using or applying. Thank you for listening. If you have any questions, do not hesitate to contact me on any channel.